Intro. Visual. Zoom out from a galaxy to Earth, then to a human, then to subatomic particles. Narrator. What if I told you that reality is far more complex than what we see? That beyond our three-dimensional world, there exists another dimension. One that could unlock the secrets of the universe? Welcome to the mind-bending intersection of string theory and the fourth dimension. Section 1. Dimensions explained. Visual. A point, 0D. A line, 1D. A square, 2D. A cube, 3D. Then an animated attempt to visualize the fourth dimension. Narrator. To understand string theory, we first need to grasp dimensions. We live in a three-dimensional world: length, width, and height. But what about the fourth dimension? Visual. A 2D creature living in flatland, unable to comprehend 3D objects. Narrator. Imagine a being living in a two-dimensional world. It sees only length and width, unable to grasp the concept of height. If we, as three-dimensional beings, lifted an object above their plane, it would appear to vanish. Now, what if we're like that 2D being, unable to perceive the fourth dimension? Section 2. Introduction to string theory. Visual. Atoms. Then zooming into vibrating strings at a microscopic scale. Narrator. Enter string theory. Instead of viewing the universe as made of point-like particles, string theory suggests everything is made of tiny, vibrating strings. The way these strings vibrate determines what kind of particle they become: an electron, a photon, or even a graviton. But here's where it gets crazy. These strings need more than 3 spatial dimensions to function correctly. Section 3. How string theory uses the fourth dimension. Visual. A 3D cube shadow stretching into an unseen dimension. A diagram of a Calabi-Yau manifold. Narrator. Mathematically, string theory doesn't just need 4 dimensions, it needs 10 or even 11. But let's focus on the fourth. The extra dimensions are believed to be curled up into tiny, compact spaces called Calabi-Yau manifolds, making them invisible to us. Just like a garden hose looks like a simple line from far away, but up close, it has a circular dimension. Section 4. Why it matters. Visual. Depictions of gravity waves, black holes, and the fabric of space-time bending. Narrator. Why should we care? Because string theory and its use of extra dimensions could be the key to unifying gravity with quantum mechanics, the holy grail of physics. If we can confirm these hidden dimensions, we might finally understand the true nature of the universe. Conclusion. Visual. The cosmos, fading to an image of a tiny vibrating string. Narrator. So, are higher dimensions just a mathematical trick, or are they real? The search for answers continues, but one thing is certain: our universe is far stranger and more wonderful than we ever imagined. Visual. Subscribe for more mind-expanding content.